Hello everyone. In this video, I'm going to talk about how to create subscribers in ROS2 using C++. Uh, the reason why this is important is that it helps you to make your robot behave differently in different situations. So what the subscriber does is that it subscribes to a topic, and this topic could be your camera, giving in data, or something else. And based on what the input is, the robot will behave differently. And in this video, what I'm going to do is that based on my input, whether the turtle sim has to move clockwise or anti-clockwise, based on just a string input, the robot changes its course of direction. In order to create a package which has a node, which creates a node which subscribes to a topic and does a particular action, what we do is we create this package called sub package, and it has the same structure which we used for a publishing package, where you have a launch file, a source file, CMakeList, and package XML. So I'll go over the source file, which is the most different from the publishing package. So first, what we do is we include the headers. Here we are going to include the geometry message twist type, and also we're going to include RCL CPP, and then we're going to include standard messages string. We include this one because we are going to have a string input to control the direction of the turtle. So similarly, we create a class which imports the RCLCPP node class, and then we create the sub node with the node name as sub node, and then we create a publisher, and then we create a subscriber. The publisher remains the same syntax, which is like this: create publisher and geometry message. We put the message type here, and then the topic name here to control the turtle sim. So the next one is the subscriber. Here what we do is we write this what we do is we create subscriber, which is this creates subscription, and then similar to the publisher, we have standard messages message type string, which we declare here, and then we declare the topic where it has to listen to. So if something is being published into this topic, then do a following action. So you can see here that the standard bind sub node, which would call a particular callback function. So this subscriber, if it receives any input, it would call this method of this class. So this is the callback method, and then we have placeholders for like able to receive that message. So if you see here, this is how that method is declared, the callback method. So you can see here it's a void callback, and then here we have const, and we create a pointer to that message, whatever the message which is being published to the topic. And what we do is we also create a message for publishing data, and we put that message type as geometry message twist. And based on the message what we receive, we need to publish this twist message accordingly. So we have an if statement where we write that message data, we point to that data which is there, and then we see if it is equal to clockwise, and if it's clockwise, we publish 0.5 in X and 0.5 in Z rotation. Then we do this to publish that message. And so this is the other case where we check for if it's anti-clockwise, and if it's anti-clockwise, we just change the angular Z to minus 0.5. And similarly, we publish it so that based on the user input, the turtle sim can go either in clockwise or anti-clockwise direction. And then here we declare all the variables for that class. So we initialize it like shared pointer publisher and shared pointer subscriber. After this class, which does all the ROS-based functions we need, what we do is we create the main function where we call this class. So we initialize a ROS2 client library, and then we create an instance of this class and make it to run continuously. So here CPP spin standard make shared subnode. That's the name of this class. And as long as we kill the process, it will keep spinning. And if we kill it, then RCL CPP shutdown and closes the entire node. So we build the package. we do call build, and then once the package is built successfully, we source the install, and once that's done, we launch our package. ROS2 launch, package name and the node. Once that's done, then we source install, and then we launch the TurtleSim node. So this would have the TurtleSim up and running, and once that's done, then we again do source install, and after that we publish to this topic direction which we created, and then we can see here that now it's going in the clockwise direction, and you can see that we need to give the topic type, and also the data, and you need to specify whether it's anti-clockwise or clockwise. So now you can see that it's moving in the anti-clockwise direction. So in this way, we can make the TurtleSim move both clockwise and anti-clockwise just by our command, which is clockwise or anti-clockwise. So that's it. This is how you set up the entire process for creating a subscriber, and you would go about controlling the TurtleSim. And this can be utilized for any other applications you need. So thank you for watching, and subscribe to get weekly robotics content.